This is a brief demonstration of the EMX Advanced Contrast Sensor, model CNTX. The CNTX is designed to measure light reflected from a target and provide a discrete output when the reflected light exceeds the user-adjustable threshold. The CNTX uses a broad-spectrum white light source that provides a small 3 mm diameter light spot. The two-digit display indicates the level of light reflected from the target. Here is an example of the CNTX measurements on a grayscale step pattern. I've wired the discrete output signal to the red LED. Whenever the threshold is exceeded, the red LED will come on. Okay, here's the white paper. Here's a 25% gray, 40% gray, 50% gray, 80% gray, and nearly black. As you can see, when the threshold is crossed, the red LED, the discrete output, will turn on. The sensor also features a 0 to 5 volt analog output that is proportional to the levels indicated on the display. Here's an example of the high-resolution qualities of the CNTX, where it's able to detect the difference between 20% yellow printing on white and the white background. Sliding a white business card into the sensor light spot, and you can see that the sensor is triggering when the threshold is exceeded. The discrete output, the red LED indicates the discrete output turning on. Okay, one of the most exciting features of the CNTX is the fast 25 microseconds response time for the discrete output. This allows the CNTX to be used in very high-speed applications. For example, the CNTX can detect a 1 mm thick mark moving at 2,000 feet per minute in a high-speed printing process. Okay, I've mounted a white disc with a 2 mm thick black mark to a rotary tool which rotates up to 30,000 RPM. The black mark will cause the sensor's discrete output to activate whenever it breaks the light beam. The discrete output is connected to the scope so that we can observe the signal as it turns on and off as the disc rotates. So let's start the tool. Right now we're at the low speed. Now we're going to switch to the high speed, 30,000 RPM. And you can see as the mark passes through the CNTX light spot, the discrete output turns on and off. We can set the scope for 20 microseconds per division, and you can see the discrete output doesn't miss a beat. So thanks for viewing this video, and visit us at emxinc.com.